When solving equations that have the x underneath some sort of radical, one thing that we need to be cautious of at the finish line is to make sure that our answers are not extraneous, not that dissimilar than what we had to consider with rational equations, with making sure that we don't end up with division by zero. So here we're kind of back to solving over the set of real numbers. We want to make sure that our solutions fit. So in this first one, we're going to approach it similarly to what we saw in the last couple of examples in the previous video, where we're going to cube both sides. So we're going to get 12 minus x equals 3 cubed is 27. We can go ahead and subtract 12 from both sides. So we get negative x equals 15, or if we divide both sides by negative 1, x equals negative 15. And checking that real quickly, 12 minus negative 15 would give us 27. The cube root of 27 is indeed 3, so we're confident that that answer holds up. In the second example, we're going to have to do a little work before we square both sides, because we cannot just square the individual pieces, we're squaring the entire side. So before we can do that, we have to isolate the radical, and then we can square both sides. So if I subtract 7 from both sides, we get the square root of 3x plus 1 equals negative 7. Let's try that again. Negative 7. So now we square both sides, and so we get 3x plus 1 over here on the left, and we get 49 over here on the right. So far so good. And then going to subtract 1 from both sides. 3x equals 48. We can then divide both sides by 3, and we get x equals 16. All seems good so far, except if I go back and plug 16 into my original problem, 3 times 16 is indeed 48. 48 plus 1 is 49. The square root of 49, if you'll recall, we're just going to take the principal root, the positive root, so the square root of 49 is 7. 7 plus 7 decidedly does not equal 0. So here's an example of where our answer ended up being extraneous, and so this problem actually has no solution. And we could have actually predicted that that was going to be the case right here. At this point, before we squared both sides, we had the square root of 3x plus 1 equal to negative. And that was a signal that something was going to end up amiss about this problem. Because when we take the square root of something, unless we're taking the square root of both sides in the process of solving, we just take that principal root, like we did when we checked our answer. But in this case, we have the square root of 3x plus 1 is set equal to a negative 7, which can't be. So that was the indication right there that this problem was going to have no solution. We actually could have avoided doing all of this work and just stopped right there and said that our answer is indeed no solution, that there is no answer because of that flashing signal there. But if you miss it, the only way you're going to catch it is if you check your answer when you're all done. Our third example has 2 separate square roots to it. And once again, I have to caution, we cannot just square the individual pieces. Just say x plus 5 plus x equals 5 squared, so 25, and solve there. When we square both sides of an equation, we're putting a set of parentheses around it, and so that means that we would have to use FOIL techniques on this left-hand side in order to multiply that out. So we have to make sure that we avoid that trap. So with that, my recommendation, we're going to have to square both sides of this equation twice. So my recommendation is to isolate the harder of the two, the more complicated of the two radicals. So I'm going to subtract root x from both sides. So I've got root x plus 5 isolated here on the left, and then I have 5 minus root x over here on the right. And so now I'm going to square both sides. So I am going to have to use that FOIL technique, but it's going to be a little bit simpler than if I had just squared both sides originally, and I'm going to make some progress on getting rid of at least one of these square roots. So on this left side, I have x plus 5. The square and the square root cancel each other out. On the other side here, I'm going to have to FOIL, so I'll write out a second 5 minus root x. And so I've got 5 times 5 is 25. I'm going to have a negative 5 root x and another negative 5 root x. Those are going to combine to make negative 10 root x. And then I've got a negative root x times a negative root x, which is going to give me a positive x, since the square roots will just cancel each other out. So now I've successfully eliminated one of the square roots. I now need to get rid of this other one. And so I'm going to do it the same way. I'm going to isolate that square root, and then I'm going to square both sides. So that means I have some work to do to move stuff to the other side of the problem. So I'm going to subtract x from both sides. Well, that conveniently enough takes care of that. I'm going to subtract 25 from both sides. So I've got 5 minus 25 is negative 20 equals negative 10 root x. So I'm getting close. I'm going to divide both sides by negative 10. And so I've got 2 equals root x. So my last step, square both sides of the problem, and so we get x equals 4. And so now we should definitely go back and check to make sure that this answer works. Didn't seem like there were any red flags, but it's always a good step to take here on these radical problems. So if I plug in 4 here, 4 plus 5 is 9, the square root of which is 3. Plug in 4 here, the square root of 4 is 2. 3 plus 2 equals 5. It indeed checks out, so we have confidence that our answer is correct.